Hey, we're going to talk about absolute value graphs today. So absolute value graphs are really special. And the first thing I want you to remember is that in our word we have absolute value. And this value, this V, is going to jump out in your head because these graphs have guess what shape? A V. Do you remember during quadratics, I kept telling you to be very careful and draw your quadratics as a U because eventually we were going to use the V somewhere else? Well, the time has arrived. Absolute value graphs are V-shaped. So today is the day we're going to draw V-shaped graphs. Okay, let's look at one. So here's my graph. We're going to start off with a nice function that looks something like this, the absolute value of x plus 3. Now, if you'll notice, my absolute value bars are there, and that really, outside of my absolute value bars, my function is still kind of like y equals mx plus b shape, right? It's not too far off, but it's not quite exact. So I just want you to keep that in your head for a minute. Okay, the first thing we do when we don't know what we're doing, the way you can always graph something, is by making a table of values. So we're going to do that. We're going to start off with a table of values. And to make our table of values, we're going to draw a little chart, label X and Y. And we're going to label our X's. In this case, we're going to start with negatives and positives. So always make sure you get a good spread of numbers. So I'm going to say -5, -4, -3, -2, -1, 0, 1, 2. Whoops, my 2 jumped. 1, 2. Okay, now, you know in your head we have to have a V. So if we don't find a V, then that should be a red flag. But let's see what we get so far. So -5 plus 3 is -2. The absolute value of -2, right? -5 plus 3 is -2. And the absolute value of -2 is 2. -4 plus 3 is -1. The absolute value of -4 plus 3 is the absolute value of -1. The absolute value of -1 is 1. -3 plus 3 is 0. Absolute value of 0 is 0. -2 plus 3 is the absolute value of 1. The absolute value of 1 is 1. -1 plus 3 is the absolute value of 2. Absolute value of 2 is 2. The absolute value of 0 plus 3 is 3. So the absolute value of 3 is 3. The absolute value of 1 plus 3 is 4. Absolute value of 4 is 4. And then 2 plus 3 is 5, and that has an absolute value of 5. So now we've made our table of values, and we're going to go plot these points. So 1, 2, 3, 4, 5, up 2. Okay. 1, 2, 3, 4, up 1. -3, 1, 2, 3, 0. -2, up 1. Oh, look, what has happened? -1 up 2. -0 up 3. 1 up 4, and I'm going to stop there because my graph is running out, and that's okay. So look what's happened. Now, a month ago, we would have said, oh, that's a quadratic function. This looks like a vertex, but it's not because remember now, this is V-shaped. So when we connect these, we're going to connect our coordinates put arrows on the end because we know this goes on forever. And here's our function. Okay, so that's what that looks like graphed. Now, does anybody see any patterns that might be worth mentioning? You know, we always love a good x-axis and y-axis. What is our x-axis here? Our x-axis, or sorry, good gracious, our x-intercept. What is my x-intercept here? It's -3. And what's my y-intercept? Also 0, 3. Interesting, because I've got a 3 over here. So maybe some patterns. Okay, let's keep going. What if we do y equals the absolute value of x plus 2? Now this looks a little bit different. And why does this look different? Because it's got the plus 2 is outside of our absolute value, but that's okay. We are going to make our table of values as per usual. We're going to pick some negatives and some positives. So I'm going to pick -3, -2, -1, 0, 1, 2, 3. Okay, so the absolute value of -3 is 3. 3 plus 2 is 5. The absolute value of -2 is 2. 2 plus 2 is 4. The absolute value of -1 is 1. 1 plus 2 is 3. 0 plus 2 is 2. The absolute value of 1 is 1, plus 2 is 3. The absolute value of 2 is 2, plus 2 is 4. The absolute value of 3 is 3, plus 2 is 5. So if we graph these, 1, 2, 3, 1, 2, 3, 4, 5, we've got to start picking things on the graph. -2, 4, -1, 3, 0, 2, 1, 3, I see we've turned around, 2, 4, and 3, 5. Okay, put these together, and we've got our V-shaped graph. Sure enough, here's our V. Now, again with the patterns, where is my x-intercept? Doesn't exist, right? Don't have one. Where is my y-intercept? My y-intercept is at 2. Interesting. Do you see a 2 here? Okay, so just like before, y equals mx plus b. And doesn't b usually represent a y-intercept? It sure does, and that's exactly what's happening here. So you'll notice that this is very similar to the quadratics we've kind of looked at. I hope you can see that. I know that's small, but here's what I want to point out. Over here, we added or subtracted a number inside the bars, and it moved our graph kind of on a left and right, like from the center, right? It moved it over here. And on this one, we added a 2 outside of the bars, and it moved our V up. Okay? So, what would you expect to happen if I made another graph that was y equals negative absolute value of x, I don't know, plus 1? Are these opening up or down? This over here is opening up. See this negative? That's going to cause our graph to open down. It's going to cause our graph to open down. Okay. Take a look at this positive 1. Isn't it very similar to this positive 3 that was inside the bars? That positive 1 is going to move our graph the opposite direction, just like we saw in quadratics. Here we had a positive 3, and it moved our graph 3 to the left. This positive 1 is going to move our graph 3 to the right, or to the left. Here we had a positive 2, and it moved our graph up 2. So this is kind of a shortcut. So if we've got, just like in quadratics, an a value, does this look pretty similar to what we did in quadratics? This a, if it's negative, it makes your graph open down. It's going to create a graph that opens down like this. This H moves it left and right in the opposite direction, just like in quadratics. So what I mean by that is if you have x plus 3, you're going to move to the negative 3, right? Opposite. And if you have the absolute value of x minus 2, you're going to move over here, right? Just like in quadratics. The k is going to move up and down. Move up and down. Okay, so if you've got the absolute value of x plus 3, it's going to move your graph up 3. And if you have the absolute value of x minus 3, it's going to move your graph down 3. Okay, so this is a really, if you're going to screenshot something, this is it. So this is what that would look like. Let's do just a couple more examples. What if we have y equals the absolute value of x minus 2 plus 3? Now, you can 100% go back and get and do a table of values. That will work every time. Every time. You can't go wrong. It's just extremely inefficient. So let's look at this. We know it's going to be V-shaped. We know it's going to open up because this is positive right here. So we're going to move our graph. This negative 2 tells me that it's going to move 2 to the right. Oops, I don't even want to point there. 2 to the right. And that positive 3 tells me it's going to go up 3. So I'm going to put a coordinate right here at 2, 3. And then I'm going to draw my V shape. Now, if you go back and look, that V shape goes up 1, over 1. It goes up in a nice, pretty diagonal direction. Unlike quadratics, that 1, 1 continues. Okay, so it goes up at a nice like steps, right? Over 1, up 1, over 1, up 1, over 1, up 1. Let's try one more. What if we have y equals negative x minus 1 minus 2? Okay, let's see what that looks like. That's going to look something like this. We're going to say we know we need to go to 1, and then we need to go down 2. So I'm going to come over 1. Remember, the horizontal move goes the opposite direction. So -1, we're going to go to the right. And then we're going to go down 2. And then our graph is negative, so it's going to open down. So I'm going to go over 1, down 1, over 1, down 1, and make my V shape. And I'm done.